Hi everyone, and welcome back to educator.com. In this mini lesson, we're going to go through the first page of the A+ Physics worksheet on gravity, and you can download that worksheet from the link right below the video here. I recommend taking a minute, printing that out, giving it a try, and then we'll come check our answers. So, starting with number 1, a space probe is launched into space from Earth's surface. Which graph represents the relationship between the magnitude of the gravitational force exerted on Earth by the space probe and the distance between the space probe and the center of Earth? Well, we know that the gravitational force equals G m1 m2 over r squared. So we've got this inverse square law relationship between the distance and the gravitational force. Can also see that as you have greater distances, you're going to have lower forces. So that eliminates number 1 and number 4. Now, because it's an inverse square law, not a linear relationship, number 2 must be our best answer. Question 2. The diagram shows two bowling balls, A and B, each having a mass of 7 kilograms, placed 2 meters apart. What is the magnitude of the force exerted by ball A on ball B? Well, to do this, I'm going to go to Newton's law of universal gravitation. Or there maybe. 2r away, we have doubled the distance. Remember that the force of gravity is an inverse square law with the distance. So effectively, we've doubled the distance, therefore we've cut the force in 4, 1/4. So 1/4 of 100 newtons is going to be, answer 1, 25 newtons. Number 6. A container of rocks with a mass of 65 kilograms is brought back from the moon's surface where the acceleration due to gravity is 1.62 meters per second squared. What is the weight of the container of rocks on Earth's surface? Well, weight is just mass times the acceleration due to gravity. Our mass is 65 kilograms. The acceleration due to gravity on Earth is 9.8 meters per second squared. So that's going to be right around 650, say 638 newtons. Answer number 1. We didn't need to know the acceleration due to gravity on the moon since we already knew what its mass was. Number 7. The graph below represents the relationship between gravitational force and mass for objects near the surface of the Earth. What does the slope of the graph represent? Well, slope is going to be rise over 1. So we're going to have change in gravitational force divided by mass. Well, if you remember, the gravitational force is also mg, so Fg, if I divide both sides by m, Fg over m is g, the acceleration due to gravity. So our slope is going to give us the acceleration due to gravity. Answer number 1. All right, let's take a look at one more. A person weighing 785 newtons on the surface of Earth would weigh 298 newtons on the surface of Mars. What's the magnitude of the gravitational field strength on the surface of Mars? Well, the way I would do that is we know that on Earth their weight, mg, is 785 newtons. So let's find their mass. If I divide both sides by g, 9.8 meters per second squared, then mass is going to be 785 divided by 9.8, or about 80 kilograms. So on Mars, they weigh 298 newtons. So on Mars, m times the acceleration due to gravity on Mars is 298 newtons. If we want g now, we'll divide both sides by m, which will be 298 newtons divided by our mass, 80 kilograms. So 298 divided by 80 is going to give us about 3.72 newtons per kilogram. Correct answer there? Number 2. All right, that completes page 1. Thanks so much for your time, everybody. Make it a great day.